Okay, let us try to find the stability of this system having one pole at the origin and we have two poles on the left hand side. So we are supposed to find what is gain margin, phase margin, and then comment on the stability of the system. Let us plot the Nyquist plot for this. So since it is a open loop transfer function, I will be writing the open loop poles, one at the origin, one at -1, one at -5. Since I have a pole at the origin, so I will certainly have a Nyquist contour which is bypassing the origin. So now this is the contour: first segment, second segment, the third segment, and the fourth segment. Of course, let us write what does each segment's value of S is. Value of S is j omega, where omega ranges from 0 to infinity. In the second segment, the value of S is r e power j theta, where r is tending to infinity, whereas theta is ranging from plus 90 degree to 0, minus 90 degree. I'm talking about this is infinite magnitude, plus 90, 0 degree, minus 90 degree. The third segment, it is exactly the mirror image of first segment, where omega ranges from infinity to 0. The fourth segment, S is rho e power j phi. So now where rho is tending to 0, whereas phi is ranging from minus 90 degree, 0, plus 90 degree. So this is how different values of S in different segments. So let us start mapping first segment onto GH plane. This is actually S plane. So now mapping of first segment, we can write the magnitude as 40 divided by omega into omega square plus 1, and it is omega square plus phi square. Write it as 1 square. The phase is, of course, this 1 over S will contribute minus 90 degree, minus tan inverse of omega, minus tan inverse of omega by phi. So let us write different values of magnitude and phase for different values of omega ranging from 0 to infinity, magnitude and the phase. When omega is 0, if you substitute omega 0, this becomes infinite magnitude and the phase becomes minus 90, because these two will contribute 0. This is minus 90. When omega is infinity, so you have entire magnitude becoming 0 and the phase will become minus 270 degree. So we have to find two more frequencies at which phase is minus 180 degree and magnitude is 1. So this happens to be omega PC, this happens to be omega GC. So let us find omega PC. So finding omega PC, you equate that equation minus 180 degree. So this I'll equate to minus 180. Alpha equals minus 90 minus tan inverse of alpha A minus tan inverse of alpha A divided by phi, close, shift cal. So you have the the frequency at which phase is minus 180 is 2.23 radian per second. Let us also find omega GC by equating this to 1. That is, if you equate this to 1, this will become omega GC, or you equate this to this. So what I'll do is 40 alpha equals, open the parenthesis, it is alpha A multiplied by, open the parenthesis, open, it is under root of alpha A square plus 1, close the parenthesis, close, into under root, and alpha A square plus phi square, just close, shift cal. So Okay, now it is 2.57. So at 2.57 I have this magnitude 1, and at 2.23 I have a magnitude of. So since anyhow I have the magnitude equation, let me find out what is magnitude at 2.23. So what I'll do now is, there's a small correction I have to make now. So since I have to find the magnitude at 2.23, I'll make it 40 divided by. So instead of alpha equals, I'll divide it by. Okay, now this is divided by, it is 40 divided by this, calculate at 2.23. 2.23. So it is 1.34. So now what actually we did is, we found omega PC, we found omega GC, we are finding what is magnitude at a phase of minus 180 degree. So it is 1.34. Let us also find out what is the phase at omega GC, that is minus 90 minus tan inverse of alpha A minus tan inverse of alpha A divided by 5, calculate 2.57. So the phase is minus 185.9 degree. So these things are important to find the gain margin, phase margin. So with these values we can actually plot the segment 1 mapping. So let us write the segment 1 mapping in GH plane. So this segment 1, which are starting from 0 to infinity, J0 to J infinity, will actually go like this. Magnitude is infinite here, so assume that this is infinity at an angle minus 90 degree. Angle is keep increasing negative direction, it goes like this, and ultimately it just ends at minus 270. So the magnitude at this point is 1.34 at an angle minus 180 degree. So if you want to map the second segment, for mapping the second segment, what we have is r e power j theta is the value of s. So what I'll do is, wherever s is there, I'll substitute that. It is 40 by r e power j theta, r e power j theta plus 1, r e power j theta plus 5. So compared to this r which is tending to infinity, this is negligible. So now can I write it as 40 by r cube e power j 3 theta. So since r is tending to infinity, I can write it as 0 at an angle minus 3 theta. Since I know that theta ranges from plus 90, 0, minus 90, so this becomes 0. It is minus of 3 into 90, minus of 3 into 0, minus of 3 into minus 90. So this is the phi value. So it is now 0 at an angle minus 270 degree, 0 degree, plus 270 degree. So this is actually a dot at the origin. This is actually a dot at the origin. So what all exercise we did is ending with a dot at the origin. Now no need to do it for the third segment. So this is done, this is done. Third segment is just the mirror image. So you write the mirror image of that. You just went there. So this is how it is going. So now we need to map the fourth segment. So for the fourth segment mapping, S is rho e power j phi. Substitute that here. So what you have, 40 divided by rho e power j phi, 1 plus rho e power j phi, 5 plus rho e power j phi. Now since rho is tending to 0, okay, 5 is more compared to 0, 1 is more compared to 0, so you end up with 40 divided by 5 into rho e power j phi. When it comes to multiplication, 0 matters most, so it is now infinite at an angle minus 5. So now substitute this 5 variation from minus 90, 0, plus 90, so this will become minus of minus 90, which is plus 90. So now it is infinite at an angle minus of minus 90, minus of 0, minus of plus 90. So this is now finally infinite at an angle 90, 0, minus 90. So this is how it goes. So now actually what will happen is, the way how your contour is moving. So let me write the contour here that contour also, so that you can make out how the contour in S and GS plane are moving. The way how this travels, it exactly travels this way. Now you can see you are starting from this point, it is this mapping. Suppose if I say this as A, this is A dash. If I say this is B, this is B dash. So A dash, B dash are same. Then you can see this is the starting of your second segment, which is the same thing. The ending of second segment is C, that's also the same point. So A dash, because if you can see here, can you see this is 0 at an angle 270 degree, it's actually C dash. So from C dash, from C this goes to D, so this is your D dash. So once you are there at D, so from here it has to take, so what is the D dash point? It is infinite at an angle, if you can see this is infinite at an angle 270 degree. Can you see this is exactly, of course, minus 270 degree. Can you see it is the same point? So the ending of third segment is the beginning of fourth segment. And how it goes? It actually goes like this. So what is this? This is magnitude infinity. So this is how it is going. So where is minus 1 now? The critical point minus 1 is actually inside this, minus 1. So now if you actually see how many number of times it has encircled, so it has encircled once here, twice. So n is actually equal to 2. And what is P here? Number of poles enclosed by this contour is actually 0. None of the poles are enclosed by this contour. So since P is 0, n is 2 from this, so shall we say Z is equal to n plus P is equal to 2 plus 0 is equal to 2. What does it actually mean? Suppose if you actually write the root locus of this, can you see this is your root locus? Suppose if I just write it, can you see this is your root locus? Will it go like this, and these two will break, and actually will it go like this? So now system is conditionally stable. Suppose if you may replace this by K, so maybe for a value of 40, system may be already unstable. So that's why the roots are already here. Roots are already here. Now I need to know what is the margin, how far it has moved, whether it has moved too far or whether it has moved a bit less only. So for that I need to find what is gain margin and phase margin. So to find gain margin, phase margin, so okay, keeping this in mind, so let us try to find out what is gain margin. So gain margin is nothing but, so I will write it here. So gain margin is nothing but 1 over the magnitude at omega Pc. So what is the magnitude you have? This is 1.34. So it's actually if I do this 1.34 inverse, it is 0.746. So gain margin is 0.476. So this is resulting due to this transfer function, correct? We got this as the gain margin for a GH of so and so. What does this actually mean here? This means that system with 40 as the root locus gain is unstable with a gain margin of so and so. So let us also find phase margin. Phase margin is what? 180 degree plus phi at omega GC. So we found that phi at omega GC is minus 185.9. So it is 180 plus of minus 185.9 degree is actually minus 5.9 degrees the phase margin. So now since gain margin is less than 1, phase margin is negative, system is unstable. Of course, you might have learnt in Bode plot that if gain margin, phase margin both are negative, system is unstable. Here also it is unstable. This less than 1 corresponds to, in terms of dB, negative. Suppose if you want to find what is the dB of this, just make 20 log of that. It is 20 log of 0.746 is actually minus 2.5 dB. Can you see this is negative, this is also negative, which is minus 5.9 degree. So system is unstable. Now we know that system is unstable because the poles are there on the right hand side. Now how much far away it is? Can I make this system oscillatory, or can I make this system stable also? Yes, it is possible, because this is a conditionally stable system. Since this system I can change the value of k, for 40 system is unstable because two roots are coming to right hand side of this plane. Suppose if I make the system with gain, with root locus gain as 40 into the gain margin, then system will become oscillatory. That is 40 into what is gain margin? It is 0.76. So what is 40 into 0.746? It's actually 29.84. If this becomes 29.84, then system is oscillatory. System is oscillatory. System is oscillatory, then when the system will be stable, if this gain is less than 29.84, then system is stable. This is root locus gain because this is in pole zero form. Root locus gain. If the root locus gain is less than this, then system is stable. System is oscillatory here. Oscillatory here. If this 40 becomes 29.84. If it is 40, system is unstable. If it is anything more than 29.84, system is unstable. That's what is shown here also. That's what is predicted here also. Now the question is, you have that unity circle, some circle being written and so on. So that concept is very simple. So now what I want to show you is, this is your Nyquist contour. Let me write the Nyquist contour like this. It's going like this in this example, and it just makes this way, and then this is how your contour is going. And I'll write the unity circle. This is, since it is 1.34, I will write a unity circle which is slightly a smaller one. It is this now, correct? So at this point, is it not magnitude 1? Let me find what the magnitude when the phase is, let me find the phase when the magnitude is 1, which we already know. You can see when the magnitude is 1, the phase is minus 185.9. So can I write it as minus 185.9 degree? So now this is your reference minus 180 degree line. This is the intersection of that unity circle with segment 1. Can I write this as the, approximately here, this is my phase margin. If the intersection goes above minus 180 degree, then phase margin is negative, meaning 180 degree minus 1. Now what is phase margin? 180 degree plus of minus 185.9. So this phase margin is 5.9 degree, which is negative. And what is gain margin? So gain margin is 1 over this magnitude. So this is circle with magnitude 1. This way you can able to understand it. So it's not difficult. Only thing is that you should predict what is the stability of the system, which you can able to do it. So once you know what is the range, of course next it is simple mapping. The mapping of first segment and the fourth segment is the main thing. In the first segment itself, you'll get most of the values, or like omega PC, omega GC. You can predict the gain margin, phase margin here itself. So next is the completion of the graph, where it crosses minus 180 degree, the critical point. The minus 1, will it come inside or go outside the, will it be encircled or not? If you can understand that, then finding GMPM is not a difficult task.